Hi, ladies and gentlemen. We are on page 17 of our pink packets, and we're looking at section 10.4, which is on systems of equations. And we learned 3 different ways to solve a system of equations. The first way is by graphing. The second way is by substitution, and the third way is by elimination. So if you're going to solve by graphing, you need to graph both lines and see where they intersect, but you have to make sure that you put each line in y equals mx plus b format. That's really important. With substitution, you're going to isolate the easiest variable in one equation and substitute the equivalent expression into the other equation, all right? And we're going to do an example of each in a few minutes so you can kind of remember how to do this stuff. And then for elimination, you're going to make the coefficients of one variable additive inverses. So they're going to be the same number but different signs of each other by finding a common multiple. Combine both equations to eliminate the variable and solve. All of this stuff is all review for you. So you should have a fixed graph that was given to you in class to help you guys out with this example that we have right here. So let's solve our system of equations that we have right here by graphing. So the first thing that we need to do is we need to isolate the variable in each equation. So our first equation is negative x minus y over 2 equals negative 5. And in order to do that, the first thing I want to do is get rid of this fraction right here, this 2. And this y is negative. So I'm going to multiply every single number through by negative 2. So I'm going to write times negative 2. So negative 2 times negative x becomes 2x. Negative 2 times negative y over 2, the negative 2's cancel each other out, so I get positive y equals negative 2 times negative 5 is positive 10. Then I just have to subtract 2x from both sides, and so I end up getting y equals 10 minus 2x. So if I want to graph this out, remember, we need 2 things, our slope and our y-intercept. Well, our y-intercept is 10, because that's the b value right here, and the slope is negative 2 over 1. So that means I'm going to go down 2 and to the right 1, down 2 and to the right 1. I'm going to keep going down 2, so here's down 2, 1, 2, and to the right 1. Here's my dot right there, down 2 and to the right 1. I'm going to keep going with this, just so I can kind of see where my lines will intersect. So down 2 to the right 1, so on and so forth, until I have my full graph. So this right here is my full graph, and hopefully you have a straight edge to use to graph this out. Unfortunately, I do not for my computer. Don't forget to write the equation on the line, y equals 10 minus 2x, all right? So now let's isolate the y in the bottom equation right here. So the bottom equation says 5x minus 2y equals negative 2. So I'm going to subtract 5x from both sides to get rid of it. So I end up getting negative 2y equals negative 2 minus 5x. Then I'm going to divide everything through by negative 2. So I end up getting y equals positive 1 plus 5 over 2x. So here, I know that my slope is 5 over 2, and my y-intercept is 1. So that means I'm going to start at 1. On the y-axis, I'm going to go up 1, 2, 3, 4, 5, and over 2. I don't have enough room to go up 5 and over 2 again, so I'm going to go down 5, 1, 2, 3, 4, 5, and over 2. All right, down 5 and over 2. So then when I connect those dots, that's my second line. So I'm going to say y equals 5 over 2x plus 1. And then where they intersect is where my answer is. So this means that my answer is going to be 2, 6. Okay? All right, so now that I've done that graphically, let's do this by substitution. The first step it tells us for substitution is to look for the easiest variable to isolate in one equation. Well, we isolated the y value in the first equation already, so I don't even have to do any more work for that. I already got y by itself. So then what I'm going to do is I'm going to write down my bottom equation. 5x minus 2y equals negative 2. And the y is by itself here, so every time I see a y, I'm going to replace it with 10 minus 2x. And then I'm going to copy the rest of the problem down, okay? And you guys were really good at this stuff when we solved this way back in January, but let's just review it anyways. So when we distribute this negative 2 through, we end up getting 5x minus 20 plus 4x equals negative 2. So then when you combine your like terms, you end up getting 9x minus 20 equals negative 2. And then you have to add 20 to both sides, and you get 9x equals 18. Divide both sides by 9, and you get x equals 2. Well, now that you got x equals 2, you still have to figure out the corresponding y value. So to find the corresponding y value, you can just take your other equation, which was y equals 10 minus 2x, and every time you see an x, you're just going to replace it with what you got for x, which is 2. So now we can say y equals 10 minus 4, or y equals 6. So again, I get an answer of 2, 6. Okay? All right, and then lastly, let's do our elimination method. So for elimination, this one's a little bit trickier, but we can definitely do this. So this one right here, what I'm going to do is I'm going to write out my top equation, which is negative x minus y over 2 equals negative 5, okay? And then I'm going to write out my bottom equation, which is 5x minus 2y equals negative 2. And what I'm going to do is I'm going to get the y's to cancel. And I can change this y over 2, this 1/2 y, I can change it into a 2 by multiplying by 4, because you need 4 sets of a half to get to 2. So I'm going to multiply the top equation by 4, okay? And then I'm going to erase this over here and write it properly over here. I'm going to multiply the bottom equation by negative 1 because I want my signs to be opposite signs. If this is negative, then I want this one to be positive, so I'm going to multiply by negative 1. So my top equation, 4 times negative x becomes negative 4x, right? 4 times negative y over 2 becomes negative 2y, and then 4 times negative 5 becomes negative 20, okay? And then on the bottom, I get negative 1 times 5x, which is negative 5x. Negative 1 times negative 2 is positive 2y, and then negative 1 times negative 2 is positive 2. Now my coefficients are the same for my y's, except they're opposite signs, so when I add them together, those cancel out. But if I add these together, I got to add these guys together. So I get 9x equals negative 18 divided by negative 9. You end up getting x equals 2. Then the rest of your work for this is exactly the same as the work that we did up here. We figured out x equals 2, so we can just plug it in like we did up here. We're not going to do that again because we've already done it. So your answer here is 2, 6. All right, so let's take a look at page 18 of our packet, and we're talking about special cases of systems of equations. So sometimes you'll get one unique solution, and that's where the lines will intersect. And the only time your lines will intersect is if your slopes are different. Okay, sometimes you'll get no solution, and that's when the lines are parallel. And in order for lines to be parallel, they have to have the same slopes but different y-intercepts. They start at a different place, but they go up and over by the same amount. And then whenever you have infinite solutions, it's because the lines will intersect with each other all the time. So they have the same slopes and the same y-intercepts. They're basically the same line. So if I have the line y equals 3x plus 7, any line that has a different slope will intersect with this line. So y equals 2x plus 5 is an example. Really, anything would work as long as the slope is not 3, okay? You'll have no solution if they have the same slope but different y-intercepts. So for example, y equals 3x plus 4, they have the same slope but different y-intercepts. And I'm going to show you graphically why all of this stuff works in a couple minutes. All right, and then lastly, if we have y equals 3x plus 7, a line that would have infinite solutions with this would look exactly the same because they are the exact same line. All right? All right, so let's take a look at y equals 3x plus 7. We're going to graph this out. So if you look right here, when we graph it out, this is what it looks like. It starts at 7 and it goes up 3/1, which you guys already know that that's what's going to end up happening. So I'm just going to change the color of this line to black so we know that this is our baseline that we're looking at. And then I'm going to graph out y equals 2x plus 5 and see what happens when I graph that out. So let's go ahead and graph that, and you see that they intersect with each other. Let me change this one to a different color so you can see it. They intersect with each other right here. So there is one solution, all right? So anytime the slope is anything different than 3, it will intersect with the line. So if you notice when it's 1, it intersected. When it's -4, it's still going to intersect. Even if I change the y-intercept, -9x plus 20. When you look at this right here, you can see that they're going to intersect. Even if I change the y-intercept and the slope, and I keep the y-intercept exactly the same, they're still going to intersect. They're going to intersect at the y-intercept. Now, if they have the same slope but different y-intercepts, so for example, y equals 3x plus 4 and y equals 3x plus 7, let's go ahead and type that in. These will now be parallel. They won't intersect with each other, okay? And then another example, I'll do y equals 3x minus 8, for example. So if you take a look right here, again, they're parallel. They'll never intersect with each other because they have the same slope but different starting points. And then if they're the same line, so if I change this to y equals 3x plus 7, they're going to intersect right on top of each other. They're literally the same line, so they'll intersect everywhere, so there's infinite solutions, okay? So here's an example of a question about special cases. So it says, consider the equation x over 4 plus y over 3 equals 1. Well, here's the thing. I don't want to even consider it in this format because of all these fractions. It's crazy and scary looking, and I don't even want to deal with it. So what I'm going to do is I'm going to multiply everything by the common denominator. And my two denominators are 4 and 3, so my common denominator of 4 and 3 is 12. All right, so if my common denominator of 4 and 3 is 12, I'm just going to go ahead and multiply every single term that I have here by 12. So when I multiply this x over 4 by 12, let's do this on the side. X over 4 times 12 over 1, you get 12x over 4, which gives you 3x. So this ends up being 3x, all right? And then I'm going to do the same thing to this next term right here, this y over 3. I'm going to multiply that by 12 as well. So I'm going to write times 12 next to this number right here. So let's go ahead and do that. So this is now going to say y over 3 times 12 over 1, so you get 12y over 3, or 4y, so this becomes 4y, and then I'm going to multiply this last number by 12 as well, because if I multiply one number by 12, I have to multiply every number by 12. So I end up getting 3x plus 4y equals 12. So then I'm going to go ahead and isolate the y, okay? So if I have 3x plus 4y equals 12, I can subtract 3x from both sides. So minus 3x, I get 4y equals 12 minus 3x, divide by 4, everything, so I get y equals 3 minus 3 over 4x. This is the original equation, all right? So now, question A. How many solutions will 3x plus 4y equals 15 have with the original equation? Explain. So the first thing I'm going to do is I'm going to isolate the y. So in order to isolate the y, I have to subtract 3x from both sides. So I get 4y equals 15 minus 3x. Divide everything by 4. And you end up getting y equals 15 over 4 minus 3 over 4x. So now let's compare our slopes. The slope of this line is -3/4, and the slope of this line is also -3/4. So they have the same slope, but the y-intercepts are different, which means that when I graph them out, they're going to be parallel. So we're going to say if the lines are parallel, then they'll never intersect. So what we're going to say is that there is no solution because the lines are parallel. And the way that we know that the lines are parallel is because they have the same slope but different y-intercepts. Okay? All right, so now let's take a look at part B. Part B says how many solutions will 3x over 4 plus y equals 3 have? Well, this time I have another fraction that I want to get rid of. So in order to do that, I'm going to go ahead and multiply everything by the common denominator. Well, there's only one denominator, and that's 4. So I'm going to multiply everything through by 4. All right, so this 4 and this 4 cancel each other out. So I end up getting 3x plus 4y equals 12. Subtract the 3x from both sides, you end up getting 4y equals 12 minus 3x. Divide everything by 4, and you end up getting y equals 3 minus 3 over 4x. And now I need to compare that to the original equation. Well, they're exactly the same. They're the exact same equation, which means that you will have infinite solutions. So we're going to say there are infinite solutions because the lines are the same, so they'll intersect everywhere. Okay, come with questions next class if you have any. I'll see you then.